Hey guys, it's Sean again from Aampe. Again, just a reminder that if you want more information about what we do, you can go to the website on your screen, aampe.com. This is the second video in my series of talking about the children's book I wrote to describe our analytic systems at Aampe. So a user story can be found on our website. Feel free to download the whole thing and read it through. These videos, the purpose is not to walk through the entire book and read it, but rather for me as both the creator of the book and the person who designed most of our data science systems to explain why we do what we do and how we do it. So in the previous video, which I recommend you go back and watch if you haven't seen it already, I talked about the problem we're facing. That as apps have users, lots of users, they don't have a way of getting to know those users well. There's so many of them and they do so many different things that there is no way to make sense of all of that behavior. Companies often try to use tools like segmentation, but that ends up covering up most of the useful information. What we really need is the behavior equivalent of a latitude and longitude, a way of locating a user, not in terms of their geography, but in terms of what they do, so we can see how similar or different they are to other users. That has lots of other uses that I will address in other videos, but what I'd like to talk about today is what we call the user landscape, which is that map of user behavior that we create in order to do the rest of what we do. So everyone does stuff. I guess that goes without saying, but we said it. If you have a user on your app, you're measuring pretty much everything they do. If you don't think you're measuring it, go talk to your engineers because you probably are measuring it. Apps by their nature are event-driven. When someone says they want to change the screen, like switch to a different screen, there's an event for that. If they want to share something on social media, there's an event for that. When they log in, there's an event for that. All of those things can be thrown away, but in most cases, they are logged somewhere so you know what people are doing. That part is the easy part. The hard part is making sense of all that information. There's a lot of different things people can do. Some of those things matter a whole lot, some of them don't, and it's difficult to really sort all of that out. So really, what makes it more complicated than anything, in my view, is that a lot of those behaviors they overlap. I don't know of a better way of saying it. Any given behavior may tell you a whole lot about other behaviors. If you take the example of, if you look at every user and you look at the time they spend on an app, and then you look at how often they visit, those two things probably don't like march in lockstep, but they probably are. One probably tells you quite a bit about the other. The more people come, the more time they spend on the app. So knowing one takes you some of the way towards knowing about the other. On the other hand, if you look at the relationship between the time they spend on the app and how often they click on notifications, that doesn't necessarily have any relationship. It may, but it doesn't necessarily. So knowing one isn't going to tell you a whole lot about the other. That makes it difficult because if you take all of that raw information that you get about your users, if you try to use all of it in its raw form, you end up stockpiling redundant information about user behavior because of this overlap. You pile all that on and it covers up all of the useful behavior that may not be very prominent because it doesn't overlap with anything else, but that's why it's useful. It's unique information that might give you a basis for approaching that user in a different way. So we need a way of denoising some of that, of getting rid of that overlap and really bringing it down to the basic measures of what your users are doing. So we turn those raw behaviors into a map. We use some math to create a few dimensions. These dimensions have very little overlap. Just think of a dimension in terms of on a geographic map, the dimensions are latitude and longitude. In the case of your users, that the dimensions could be any number of things. Think of all of the different ways they could engage in purchase behavior, for example. That may be a dimension. Or their visit behavior, or watching videos. Maybe watching videos and commenting are actually part of the same dimension. Often these dimensions aren't humanly interpretable. They aren't things that you can just look at it and put an easy label on. Sometimes they are, but often they aren't. But the important thing about these dimensions is that they do not overlap. Therefore, they're easier to use than the raw measures. They form a landscape that we can put the users on and see their relationships the same way we would if we could put pins in a map for geographic relationships. So once we have that, we want to use it to learn about what works when we want to talk to our users. Now, at first, it may seem easy to do that. This is basic A/B testing or split testing or any of the other terms people use to talk about it, the example I have here is, say we want to learn which day of the week is a better day to talk to people. So assign different users the same message, but give it to them on different days and see which one performs better. If that worked consistently, life would be a lot easier, but it doesn't work that well. It certainly doesn't work consistently, and there's a reason for that. Those kinds of approaches can be short-circuited by random noise. So in this example I have right here, look at the blue dots. Say we're just trying to choose between Friday and Saturday, just to keep it simple. So we can randomly assign Friday or Saturday to users. Like you take a jar and you put a ball in there that's labeled Friday and a ball in there that's labeled Saturday. And for every user, you shake up the jar and you reach in, you pull one out, and that's the day they're going to get their message. That's easy enough to do. And then you can look at who responds. In here, the filled dots are the ones who actually responded to the notification. If it's not filled, that means they ignored it. So that in and of itself seems like a reasonable approach until you consider the fact that what we're trying to do is get those users to click on a notification. And some users are more, let's call them clicky. They're more clicky than others. There's a dimension of clickiness in their behavior, and some don't click on anything. They see a notification and they say, you're gonna have to give me like new and surprising information to get me to click on anything. And others, they see a notification and they click just as a matter of course. It's just what they do. So what I've done here is I have ordered these users in terms of clickiness. On the far left, my left, those are users who they have not clicked on any notifications in the last month. And on the other side, you have users who've clicked on all of the notifications they received in the last month. And it's not surprising that you see, as you move up the scale, you tend to see more of these filled blue dots, people who clicked on the notification. But if you look at the Friday and Saturday assignments, the F's and the S's, that looks pretty random. It is random. I used a random number generator to get that sequence. So using this example, 47% of those who were given a Friday message clicked, and 55% of those who got the Saturday message clicked. So we would naively assume that Saturday is better. The problem with that is that random differences fooled us. If we take the least clicky 50% of users, the ones who really are predisposed not to click in the first place, 70% of our Friday assignments went to those users, the ones who don't click as much anyway. But only 40% of our Saturday assignments went to those. So Saturday wasn't actually better. We stacked the deck against Friday by assigning it to users who were less likely to click anyway, just as a baseline behavior. That is so often the reason A/B tests end up yielding information that should not be acted upon. where they make it look like one option is better when in fact it's not. In fact, it may even be worse. So what does this all have to do with the user landscape? We use the user landscape to avoid this problem. So clickiness is one dimension of behavior. And you could say, well, all right, we'll incorporate that in. We'll take the information about how clicky a user is, and we will make sure that we assign all of the days we want to investigate, or whatever it is we're testing, to those who have low clickiness and middle clickiness and high clickiness. But then you think, okay, but what's the notification about? Maybe it's telling them to watch a certain video or try a certain food or purchase a certain piece of clothing. And those things all have attributes, genres, cuisines, colors, styles, things like that. And what if you randomly assign users who prefer Italian cuisine to the noodle menu, and you assign those who don't prefer Italian cuisine to the burger menu? You're going to get different results because you didn't incorporate that information. So you say, okay, well then we'll incorporate that. And pretty soon you're back to this original problem of you have all of these behaviors and it's not really clear which ones are relevant to any given test you're doing. And even if it was, how do you pull all of that together? That's a big, messy plumbing problem of deciding where all that goes and getting it to where it needs to be. So we use our user landscape to keep us from being fooled. We get a map. So you could have any number of dimensions. You could have, theoretically, hundreds. Many times our customers will have dozens. In this case, to keep it simple, I've picked an example with just 5 dimensions. So there are 5 major ways that these users in this app system differ. And in this case, you can read the gray to blue spectrum as like south to north. So if they are low on the spectrum, then they are gray. If they are high on this dimension, then they are blue. And so you can see the first dimension. This is set up in a very specific way. The first dimension you can see is running more or less from low to high. But then the second dimension is running in chunks of low to high, and then low to high, and then low to high, and low to high, repeating. And then the next one is in smaller chunks, low to high, 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 and so on. We do that because having the landscape organized that way allows us to then make our test assignments in a way that keeps us from being lied to. So if we go back to this example of Friday versus Saturday, we have 2 options. How do we make sure that we are getting information about the performance of those 2 options, Friday versus Saturday, that isn't actually just measuring differences in baseline expectations about users? What you do is you find a cluster of 2 users, meaning 2 users who are right next to each other on the map. They're neighbors. So if you take 2 neighbors and you assign one of them a Friday and one of them a Saturday, you have now guaranteed that 2 people who are very, very similar behaviorally have gotten 2 different options, which allows us now to compare what happens when 2 people who are very similar get different things. And then if you draw those groups, those clusters of 2 people from all across this user landscape, as you can see, all of these vertical boxes where we draw it from all the way across, what you now have is you assign a Friday and Saturday here, and here, and here, and here, and here, which ensures that you are assigning different users the same message. So you have a Friday here in the landscape, and a Friday here, and a Friday here, and a Friday here, and a Friday here, and same goes for Saturday. So by assigning different messages to similar users and similar messages to different users, we have now gathered information about all of the ways that our tests can interact with important differences in user behavior. This makes complicated tests fairly easy to do and still keep them from lying to you. So, I mean, in this case, I thought up an example where, say you wanted to learn how often you should communicate to a user. That could be just once every day. It could be once every 7 days or somewhere in between. What time of day? Say you have 5 windows where you can communicate to them. And then let's say you have 3 different calls to action. You have an excited one that's maybe a little bit bossy, and one that's just super minimalist. So that's 7 frequency levels, 5 times a day, 3 calls to action. That's 105 different possibilities that you could assign to any given user. All that means is you pull a cluster of 105 users, and you pull clusters of 105 users from across the landscape. You still have this result of similar users get different messages and different users get similar messages. That allows us to compare things. So the reason I start with the user landscape is that this matters much more than any algorithms that we use later on to analyze the actual effectiveness of different forms of communication. That context is everything. And if you don't know that context, you are going to end up, at best, missing a lot of important details. At worst, you're going to end up accepting lies that manifest themselves simply because you ended up fooling yourself through randomness. So what excites me about this is that if we assign messages based on the landscape, we're actively creating the information we need. If you want to know something about how a user is going to respond to some aspect of communication, it could be the timing, the day of week. It could be actually a part of the message, what call to action or what value proposition, what incentive, what level of incentive. Is it 10% off, 20% off? There's all different kinds of things you could think about that might influence the way someone's going to respond to you when you talk to them. And if you want to know how people are going to do that, you don't have to sit there and hope that maybe someone's going to tell you. You can go out and get that information. That's an extremely powerful thing to do. And the only reason it's possible is because we have set up a landscape that allows you to do that systematically. So when you get the information, it can be used. That's more important than any of the math that we do. As is one other thing that I will talk about in the next video. So far I have talked about the problem of understanding users at scale and how difficult that is. And I have talked about the user landscape, which is our map of user behavior that allows us to say these users are really close together and these users are really far apart. And we can use that to set up tests that won't lie to us the way naive A/B tests will. Next up, I'm going to talk about the rewards menu. That is the way that we assign priorities to different things users could do in our system. So when we do eventually model, we can take into account that them purchasing something is worth a lot more than them watching a video, which is worth a lot more than them just coming to the app and doing nothing. We need that information to be able to learn about what's really valuable and what works. The video after that, I'm going to talk about our what-if model. That's where it combines all of this user landscape and rewards information into a model that looks at all of the different possibilities. It's a way of imagining at scale. And then the last part I will talk about is what is the point of all this? Why are we so focused on optimizing push notifications, and why are we so intent on focusing on full scalable personalization at the individual level and not simply one of the more clumsy tools like segments? So I will get into all of those, but those are in different videos. Thank you for joining me this time, and I will see you in the next video.